Hello friends, welcome to the lecture series on engineering graphics. I am Dr. Shivraj Narayan, Professor of Mechanical Engineering at VNR VJEC. Now let us move towards the demonstration of the same problem in AutoCAD. So I have already opened this template and now we'll move towards the solution. The very first step says we need to draw the fixed straight line AB, which is directrix. So using line command, I'll make the ortho on. I'm drawing a straight vertical line of any length. So this line represents the directrix. Next, again using line command, somewhere on this line I'm drawing a horizontal line. So this horizontal line represents the axis. So the vertical line is, this line is the directrix and this horizontal line is the axis. On this axis line, we are supposed to mark the focal length. So again I'll make use of line command. From this point, I'll mark or I'll measure the distance as 65 because 65 is the focal length that is given to us. So what I'm doing is I'm drawing a line of length 65 mm. So this is the focal length. The next step is we need to divide this into some number of equal parts. How many parts? So those number of parts are defined by the values that are given in the numerator and denominator. So the given eccentricity ratio is 3/2. So the addition of these two values is 5. So that means this line should be divided into 5 parts. Now before we make the division, we will make use of a command called as p-type. And by doing this, what we try to do is we are trying to change the shape and size of the point so that it is clearly visible to us where the divisions are made. So select any one of the required shape, define the size as 5 and click on this set size in absolute units and then click OK. Next, type divide command, select this focal length line and we know that we need to make 5 parts. So enter the number of segments as 5 and press enter. Now you can see the software is showing us 5 divisions. So 4 points are indicated. The 5th one is nothing but the end point of this line. Next, I'll make use of the text command and I'll write down the name of the fixed straight line. So this is A. I'll copy this and I'll place it at different locations. So here I'll get point C. At this location it will be B. The end point of this line will be focus F. And somewhere here we'll call this as C. So I'll double click on this. So this is C. Similarly, double click and edit it to F. And this one will be B. Similarly, on this side also double click and make it C. So what I know now is the CF has been marked. I have divided the focal length into number of equal parts. Now I need to show the vertex. So we know that the given eccentricity ratio is E is equal to VF by VC is equal to 3/2. So compare the numerator part, that is VF is equal to 3. So we are only considering the numerator parts. So what does it mean? It means that vertex V is at 3 divisions distance from F. So this is the F point. So this end point is the F point. This is the first division, second division and third division. So this point is nothing but our vertex location. So I'll copy this F and place it over here. Double click. And change it to vertex V. The next step is from this vertex V, we need to draw a perpendicular line whose length is equal to this VF. Now, how do we do that? So you can take this V as center, VF as radius and draw an arc. That is one way. Or if you know the focal length, which is 65, and we have divided this focal length into 5 parts, that means each division is of 13 mm length. So 13 into 3 is 39. So you can as well draw a perpendicular line of 39 mm. So I'll make ortho on line command. I'm picking this third point from the focus F as the starting point and defining 39 mm as the length. So this point is nothing but B point. So I'll copy the text and place it over here. So this is endpoint B. Now join C with B and extend. So this is joining C with B, and you can see the angle is 56. So this 56 degrees angle you can maintain and draw the line continuously, or you can as well make use of extend command. So what we have done is we have drawn the focal length, divided it into number of equal parts. This number of parts are defined by the numerator and denominator given in the eccentricity ratio. Then we have identified the vertex. Then from vertex V, we have drawn a perpendicular line. This perpendicular line length is nothing but equal to the distance from V to F. Then we have joined this endpoint C with the endpoint of the perpendicular line, vertical line, which we call it as B. So we are joining C with B and extend. Now once we do that, what we need to do is towards the right side of vertex, we need to mark some number of points. Towards the right side of vertex V, we need to mark some number of points. And through those points, we need to draw perpendicular lines. So before we do that, I'll just slightly move this sketch downwards. I'm making use of move command and shifting the entire sketch downwards. And I'm also showing you the usage of the extend command for extending this line CB. So randomly I have drawn one line over here. Then I'm typing extend and selecting this line. So you can see the line has been extended. Now you can erase this temporary line. Now how do we draw the perpendiculars onto the right side of vertex V? So what you can do is first copy this directrix and place it at the location of vertex. So what I have done is first I have copied this directrix line and then placed it at the location of vertex V. Now you make use of offset command. Define the distance as 10 mm. Select this line and place it onto the right side. So what I have done is I have first copied the directrix line, placed it at the vertex, and from vertex V towards the right side, I am simply offsetting this line at a distance of 10 mm. So what should happen is basically these perpendicular lines, they should meet this extended line CB at some points. So now I will erase this line that we have placed at vertex because that is not needed. Then using extend command, extend these lines up to extended line CB. So wherever these lines are touching this extended line CB, they are our new points 1 dash, 2 dash, 3 dash. So I'll make use of the copy command and place the text over here. So this is for 1, this is 2, 3 and 4. Similarly, here we'll have 1 dash, 2 dash, 3 dash and 4 dash. Now double click and edit this text. So this is 1, this is 2, 3 and 4. Similarly, edit the text on the top. This is 1 dash, 2 dash, 3 dash and 4 dash. Now once we have obtained this 1 dash, 2 dash, 3 dash, 4 dash, the next step is to measure these distances. So measure 1 to 1 dash distance. Similarly, measure 2 to 2 dash distance, 3 to 3 dash distance, and use these distances for obtaining the points on hyperbola curve. So I'll make use of the distance command. So measure the distance from 1 to 1 dash. It is 53.91. Then make use of arc command. Go to center option. Fix point F as the center. I'll repeat, distance from 1 to 1 dash is 53.91. So now arc command, center option, pick the focus as the center point, type 53.91 as the radius, press tab key, draw an arc on line number 1. Similarly, use distance command, find the distance from 2 to 2 dash. It is 68.82. So again make use of arc command, center option, pick the focus as the center, type 68.82, press tab key and draw an arc on line number 2. Similarly, measure the distance between 3 to 3 dash. This is 83.73. Go to arc command, center option, F as center, define 83.73 as the distance, press tab key and draw an arc on line number 3. Same way, measure 4 to 4 dash. This is 98.64. Arc command, center option, focus as center. 1 minute. Distance 4 to 4 dash, 98.64. Arc, center option, pick F as center, type 98.64 as the radius and press tab key and draw an arc on this line number 4. Now once you draw these 4 arcs, use mirror command, select the 4 arcs, press enter. Then it is asking you to define the mirror line. So first point of mirror line is this C and the next one is the other C. I'll repeat, mirror, select the 4 arcs, press enter, then define the first point of mirror line and the second point of mirror line. Then it is asking you to erase source objects, so click on no, and you will be getting the similar arcs on the other side of axis. Only thing is these arcs are not touching the line, so you can make use of extend command and extend it like this. Now these lines and arcs, they are meeting at certain points. Those points are nothing but the points on hyperbola curve. Now make use of spline command and join these points continuously. So you need to pick all these points wherever the arc is cutting the perpendicular lines. So we have selected or picked all the points. Now in order to close this, click on end tangency and now position the cursor so that the arc the curve looks smooth. Whichever position you get that smoothness of curve, you click to terminate the command. So this is what is the hyperbola curve that we have constructed using general method of construction. And in order to make this as our final answer and a prominent outline, what we do is we go to the properties. We'll select the curve first, right click, go to properties, then you can change the color and then you can change the line weight. So I'm selecting 0.35 as the line weight. So by doing this, what happens is we will be able to show the final answer as prominent one. So hyperbola is now very clearly seen over here. Next, you need to name it because we have marked so many points over here. So copy one of the text point and place it over here. So this is point number P1. So double click, edit, type P1. And since we are making use of yum text, we have got the provisions to use subscript and superscript. So I am selecting 1 and clicking on this subscript. So by doing this, I get the proper notation P1. Copy this and place it at the remaining positions. Double click on this and change it to P2. Similarly, P3 and similarly P4. Now same way we can position them on the downside. You can mirror this or you can copy them. So we'll go with the copy. Copy is the best option over here. So we'll pick this P1 and place it on the downside. Double click on this and add dash at the end. So this becomes P1 dash. Copy this P1 dash and place at the appropriate positions. Now double click to change the names to P2 dash. Next is P3 dash. And next one is P4 dash. The second part of this problem, it states that we need to draw a tangent and normal to this curve and the distance is given as 50 mm from focus. So now we'll make use of arc command, center option, pick F as center, define 50 mm as the radius and press tab key and draw an arc such that it cuts the hyperbola at one point. So we will call this as point P. So I'm copying this and placing it somewhere over here. We'll double click this and edit it as P. Now join this P with F to obtain the line PF. So now we got the line PF. What is the next step? Now we need to draw a line which is perpendicular to this line PF, but it should start from this focus F. Now how do we get that? So for that we need to make use of OSNAP features. Go to the OSNAP settings, clear all the OSNAP features, just keep perpendicular on. So we are making this perpendicular as on. Go to the line command, move the cursor over this line. The moment you move the cursor over the line, the software is highlighting or indicating the perpendicularity OSNAP feature. So click on this line and then draw a line such that it goes up to the fixed line directrix. So what we have done is we have drawn a line which is perpendicular to this PF line. But what is our requirement? That this line should start from focus F and not anywhere else. So we will now make use of move command. So type M, press enter, select this line. You need to pick the endpoint, and because you need to pick the endpoint, you just make endpoint as well as intersection on. These two OSNAP features you can make it on. Select the object, press enter. Now pick this endpoint and place it at focus F. I'll repeat. Move, select the line, press enter, pick the endpoint and place it at F. So by doing this procedure, what we have done is from F we have drawn a line which is exactly perpendicular to PF. Since this line is not touching the directrix, I'll make use of extend command. So through extend, I have extended it up to directrix. I'll copy the text. So this is point S, P is already there, and somewhere here we'll write down T. So join. First I'll change the text. So we'll call this as S and this as T. So go to line command, start a line from S and it should go through P and you should extend it further. So how do we do that? So this is the line which needs to be extended. So make use of extend command and go on picking this line. So this is how you can extend this line. So this line is the required tangent. Line ST, S up to T is the required tangent which is passing through P. Now in order to draw the normal, what we have to do? We need to draw a line which is perpendicular to ST. The line should be perpendicular to this ST, but at the same time it should pass through point P. So similar process we can adopt. So go back to OSNAP settings, make everything except perpendicular off. So that means perpendicular feature should be on, remaining all are off. Go to line command and move the cursor onto this tangent line and draw one line like this. So we have drawn a line which is perpendicular to tangent, but it is not passing through P. So move this line. So select the line, press enter. Because we have to pick the endpoint, just go to the OSNAP settings and see endpoint and intersection are on. Pick this point and place it exactly at point P. So this line is basically your normal line, but it should be extended onto the other side. So use extend command and start extending just by clicking onto this ends of the line. So select this line as well as the tangent line, right click, properties, and you can give some color as well as apply the line weight. I'll make use of copy command, place it here, copy, select this B, press enter, double click, edit it to N, similarly double click, edit it to M. So this is how we construct a conical curve like hyperbola using general method of construction or the eccentricity method. So not only we have constructed the curve, but we have also drawn the tangent and normal to this curve at the given distance. One of the question that is asked is name the curve. So that is why I have placed this alphabet B over here, double click on this and type the name of curve as hyperbola. And we have made use of method called as general method of construction. Also remember this by name: focus directrix method or eccentricity method. So like this you can solve the problem, and the remaining thing is only showing the dimensions. The CF is 65 mm, PF distance is 50 and eccentricity is 3/2. So I'll make use of copy command, double click this and type small e is equal to 3/2. So this is the representation of eccentricity. Remaining distances also you can show in the textual form. So press enter and you can show CF is equal to 65 and PF is equal to 50. So this is the complete solution of construction of hyperbola curve using general method of construction. So I hope you have understood this. So now what I want you is to follow the same procedure for the construction of the second bit, which is eccentricity is equal to 1, which means parabola curve, and similarly for the third bit where eccentricity is 2/3, which means it is ellipse curve. You need to follow the same steps, you will be able to get the solution. So in the next session, we will cover the remaining portion of engineering curves. Thank you.
Like, share, comment, and subscribe VNR Digital Learning Resource YouTube channel.